Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department, Akgec Engineering College. Today we are going to discuss the topic instruction cycle in the computer organization and architecture. Basically, this particular instruction cycle is having that how the memory, how the instructions will be going to fetch from the memory. So first of all, we have to understand the starting topics or starting the fundamental topics related to the instruction cycle. After that, we are going to the instruction. The first thing, that is a control unit. The control unit is a component of the central processing unit, as you already know. Control unit is actually what? That is a unit that monitors the signal, whatever is going on from one source to the another destination, or you can say the one hardware component to another hardware component. Whatever messages or whatever data transfer is going on, that will be monitored and controlled by the control unit, and control unit is the part of the CPU. Now the functions of, mainly the functions of control unit, that is what? It coordinates the sequence of the data movement into the out or out. It interprets the instructions and also handles the multiple tasks such as the fetching, decoding, execution handling, and so on. So actually the control unit is designed by the two methods, that is a hardwired control unit and the microprogrammed control unit. And when the control unit is designed by the hardwired, such as a sequential circuit or a combination circuit like your decoder, encoder, multiplexer, decoder, if the control unit is designed by the all the control hardware part, then it is called as a hardwired control unit. So further we are going to, and the microprogrammed is what? Microprogram control unit, when the control unit is going to be designed with the help of the microprogram, then it is called the microprogrammed control unit. And all the micro operations are performed, and executing a program consists of the micro instructions. Now this is the simple diagram for the, actually it is the basic for, that's why we are reading here. First we are reading this hardwired control unit. After that, on the basis of this, we are reading this instruction cycle. So first of all, we have to understand that there is a hardwired control unit. What is the hardwired control unit? Control unit is designed by two methods, hardwired and microprogrammed. In the hardwired control unit, if the control unit is designed with the help of the sequential circuit or the combinational circuit, then it is called the hardwired control unit. Now here you can see, here there is a decoders are there and the sequence counter is also there. So this is a hardwired control unit. Here the instruction register is there. This instruction register is what? Actually what is going on here, that there is a memory. In the memory, the currently executed instruction, whatever the value, that will be stored in where? That is in the MER. When the currently executed instruction are there, so the currently executed instruction is stored in the memory address register, the address of that particular, and this particular value will be fetched here. So you can see, simply the first step is what? First step is that you are fetching the value MER to IR. IR is the instruction register, that is a 16-bit value, and there is a memory address register. Now this is the 16-bit. Now the 0 to 11 is used as a address, that is the 12-bit. That is 12-bit of the address, and next is the this 12 to 14, that is represented as opcode, and the first, this is called as a mode. The 1 bit is called as a mode. So you can see here there is a 0 to 11 means what? 0 to 11, or you can say the 12-bit is representing the address, whatever file you are fetching from here. And the next is the opcode. Opcode is what? Opcode is that operational code, whatever operation you are going to perform on your operands, that is the opcode. Here only 3 opcodes are there, 12, 13 and 14, means 3 bits are there, means only 3 opcodes. So in this time, only the 3 opcodes, the total number of operations we can perform in this particular computer is what? Only 2 cube, because the opcode value is a 3 bit. So only 2 cube. That means we require to extend this. Otherwise, only the increment, decrement or whatever the operations is there, only 8 operations will be there. But we needed more. That's why we are using here as a 3x8 decoder. In the 3x8 decoder, input is 3, that is 12, 13, 14 and 3x8, because decoder is what? Decoder is a combination circuit in which you are performing that n into 2 to the power n input. So 3 is the input value and the 8 is the output. So 3x8 decoder is there. This 8 is 0 to 7, 0, 1 to 7 value, and this value is represented as D0 to D7. These D0 to D7 values go to the control logic gates. Now, there is every time these decoded signal will be changed. In this particular time, there is a time signals are also there, because there are the instruction register size is what? Instruction register size is 16 bit. That's why the timing signal will be what? Timing signal will again the 16 bit value, and you are going to represent this timing signal as T0 to T15. Just like in this IR register, you are represented as IR0 to IR15. Both are the 16 bit value. That's why the every time, every click, there is a timing signals will be changed. So now we know that there is a 16. Output should be 16. So definitely, if reverse order, definitely there is a 4x16 decoder. So that's why here 4x16 decoder is there. Now, in the 4x16, the input value is the 4 bit. This input value is 4 bit, means we are calculating here with a 4 bit sequence counter. Every time sequence counter will be incremented by 1. So here there is the increment register and the clear value and the clock value. So this is the simple value of the hardwired control unit. Remember that. Now this is the timing and control signal diagram, in which how these values with the help of the T0 to T signal. It means what? If I am writing here, that is the D0 I1 is sequence plus 1. It means what? When the D0 will be activated, whatever the D0 is there, when the D0 will be activated, then all the other D1 to D7 values will be deactivated, and when the D0 will be 1, that time the sequence counter will be incremented by 1. I am taking just as an example. You can see here there is a D3 T4 of SC0. It means what? When the D3 signal will be activated at the time T4, this time the sequence counter will be 0. It means what? Here there is a signal. These are the what? Actually these are the opcodes. So D0 to D7. So when the D3 will be activated, means when the D3 will be 1, at that time the sequence counter value will be 0. Whatever operation is going to perform, you can write whatever values. Means if you are writing D5, T6, it means what? Or you are saying SC is to SC plus 1. That is the same thing in the timing signal. What is the meaning of this? D5 signal will be activated at the time T6 click or T6 time clock, and at that moment the sequence counter will be incremented by 1. So we have to understand that what are the values of the T0, T1, T2. Fine. Now, the first timing signal, that is a T0 is AR, PC to AR. PC to AR means PC is what? Program counter value. In the program counter value, it means what? You have a memory, hai na? This particular memory is what? This memory having a some particular data is there. Suppose that you want to access this f1.txt file, and this particular file is residing in the 2004 address. It means what? That is the physical address of the f1.txt. This time, this is the currently executed address. Means what? In this address, this MAR will be stored as 2004, and the PC will store what? PC is the program counter, and the program counter will store the address of the next executed instruction. Whatever instruction is going to be next executed, its address will be stored in the program counter. So definitely here the program counter value is 2005. Here, what is the meaning of this? PC2ER. At the timing signal, from memory to address register, you are fetching the instruction and store that. That is the PC2AR. Now, this is the instruction cycle now. In the instruction cycle, actually what is the instruction cycle is here? That is, it is just like there is a fetch first, then decode, next is the read, and next is the execute. This is the 4 phases of instruction cycle. 4 phases of instruction cycle is what? Fetch the instruction, then decode the instruction, then read, and then execute. Fetch, decode, read. These are the 4 phases of instruction cycle. You have to remember this. Now, one by one, we are going to explain this, which type of, how you are going to fetch the instruction. Fetch the instruction means what? You are fetching the instruction from memory to instruction register. Fine. So here, you can see here, that is a PC2AR. This PC2AR means what? You have a memory, this particular memory, and there is a instruction register. You are fetching the particular file and store here in the instruction register in the T0, PC2AR. In the second step, this PC will be incremented by PC plus 1, and it is going to the IR. That is the IR to MAR. As we discussed earlier, that is for MAR to IR at the T1 time. T1 time, you are reciting this MAR to IR register. This MAR to IR. Now, in this case, MAR to IR, at that moment PC will be incremented by 1 because the next instruction is going to be executed. Now, the last one, here you can see here D0 to D7 is the decode IR. You can simply understand by this. There is an instruction register. Instruction register is 0 to 11. That represent the address. Next is 0 to 14. That represent as opcode. And next 14 to 15. That is the mode. Fine. This is the 3-bit value. This is the 12-bit value. And this is the 1-bit value. As we already discussed in this hardwired control unit. In the instruction register, there is a 0 to 11, 12-bit, 12 to 14, there is a 3-bit, and 15, that is the mode. Which type of addressing mode you are going to use while fetching the instruction and executing the instruction. Now, with reference to this, third line you can understand by T2. At the time T2, D0 to D7 means what? D0 to D7, that is the opcode actually, where you are using the 3x8 decoder. So, D0 to D7 decode IR 12 to 14. This opcode is actually what? That is 12 to 14. So, and the next is IR 0 to 11. Actually, this is what? This one. IR 0 to 11, that is the address, and this address is the stored in the AR. You can also write here as a MAR. Memory address register or a address register, both are the same. And next one and the last one is what? The 15th bit of the IR. 15th bit of the IR, that is the last bit. That represents the mode. That is by I. IR 15 to I. Fine. So, here now, you can easily understand this 3, T0, T1, T2, this 0 to 11. 0 to 11, that is the address. This is the address, and this address, how it comes? Because of that, there is a memory, and memory while fetching your instruction, fetch the instruction and then reading the instruction. This fetching of the instruction is going on here, 0 to 11. It means what? Here you can see in this IR, AR is IR 0 to 11. Means what? Address register and of the instruction. This is the complete instruction register. In the instruction register 0 to 11 bit. You can write simply here. IR 0 to 11 is what? Actually the address. The address is going on here. Address register or a memory address register. Next, IR of what? 12 to 14. IR 12 to 14 is what? IR 12 to 14 is actually the opcode. And this opcode is actually what? That is D0 to D7. Simple. Next, IR 15. In the IR register, the 15 bit. 15 bit is represented as I. So, you can write simply that is I. This third line. That is the same. That is D0 to D7. Decode IR 12 to 14. And next AR IR 0 to 11 and IR 15th value is going to the I. Simply you can understand by this. Now the instruction cycle. This was the T0, T1, T2, T3 and now the instruction cycle. Before instruction cycle, you have to understand the type of the instruction. There are 3 types of the instruction. That is, first one is the memory reference instruction, second is the register reference and the third is the input output instruction. In the memory reference instruction and the second is the register reference instruction and the third is the input output instruction. In the memory reference instruction, you can see here there is a 0 to 16, again just like the IR instruction register, and the computer instruction mode is what? That is I, opcode and address. That is the computer instruction mode. Now, you can see here 0 to 11 represent the address, 12 to 14 represents the opcode and 14 to 15 represents the I. That is the I is the mode. Now, how you can understand that this is a memory reference or this is a register reference? With the help of the opcode. If your opcode is 0 to 6 or 00 to 110, then definitely it is a memory reference instruction. And if your opcode is 111, then two conditions are there. That is, the first condition is there, register reference instruction in the I mode is 0 or I mode is 1. 1 means input output, I equal to 0 means register reference. You can summarize this value as simply, that means that is, if your opcode is 0 to 110, it means what? Definitely it is a memory reference instruction. But again there are 2 things. If the memory reference instruction, there is a first thing, if the I mode is 0, means this is the direct memory reference instruction, and the second mode, if the I equal to 1, then there is a indirect memory reference instruction. First thing. Now in the second condition, opcodes are, your opcode is 111. Opcode, it means what? Definitely the 2 values are there. First is the register reference. It can be register reference or it can be the IO. Now you have to check. In the register reference, if the I equal to 0, it means your instruction lies between the register reference instruction, and if I equal to 1, it means it is the IO or input output instruction. Fine. You can take a simple example. Simple example is like, if I am giving you this. I am giving you a 16-bit value and you have to find out which type of instruction is there. So, firstly, in the first step, what you are going to check? Your MSB 2, 3 and 4. Your MSB. MSB is the left side of value. So, you have to represent this. There is a 111. It means what? Your MSB is this 111. You have to check only this one. 111 is there. Now in this 111, it means what? It can possible that it can be a IO or a register reference. Now again you have to check the mode. This one is the mode. Now you have to check that your mode is 1. It means what? Answer is definitely it is a IO reference instruction. Simple. That is the IO reference instruction. Now, in this type of instruction cycle, there is a first thing. First thing you can check, a start of sequence counter is 0. Next is the PC to AR. PC to AR means address register is there at the time T0. And in the next T1, in the T1, again the same things are there. T0, T1, T2, and we can already read this. T0, T1, T2. In the T2 you can represent in the T0 and T1. All these things are written over here. That is in the T0, PC to AR. Then in the T1, MAR to IR. Memory address register to instruction register. Next is the decode operation as the T2. As you can see here, that is a IR 0 to 11 going to the AR, and the mode IR 15 is going to the I, and opcode is going to the decode operation. Now, after that, you have to determining the type of the instruction. In the type of the instruction, always we have to check the D7. In this D7, that is calculated as a mode, if there is a 0, then it can be possible. This is the memory reference instruction. And if D7 is 1, so it means it can be possible that it is a register reference or the IO instruction. In the D7 equal to 0 means there is a indirect value, again the mode and the 0. If I equal to 1, indirect mode, and if the I equal to 0 means direct reference instruction. Because the direct reference instruction, there is no calculation of the effective address. And if it is indirect address, so you have to calculate the effective address. That's why here it is written as MAR to AR, because this is the time for effective address calculation. Now again the D7 equal to 1. If the D7 value 1, then the IO you have to check. You have to check the mode is what? What is the mode of I? If the I value is 1, definitely it is the input output instruction. If the I equal to 0, then your instruction is register reference instruction. As you can see here, that is the type of the instruction. Thank you.